Okay, so let's take a look at a couple problems dealing with derivative of inverses. So again, let's just call g of x the inverse of f. And I give you a point on f. I give you the derivative of f at that point. I want to find g of 4 and g prime of 4. Okay, so let's start with g of 4. I need to figure out what g of 4 is. Okay, I like to kind of just write it as an ordered pair. So this is what I'm looking for. But again, here's the idea. If f and g are inverses, that means your x and your y values are switched. So this 4 would be the same as the y value on f. So this question mark is the same as here. But they told me that f of 12 is 4, so this is 12, right? F of 12 is 4. That's what they're telling me. So then I know that the 12 has to be the y value on the g function. So that gives me g of 4 is 12. So I have that. Now I need the derivative of g at 4. So I'm going to use the formula for the derivative. So the derivative of the inverse, and I would just start saying it to start memorizing it, is 1 over, it is the derivative of the original function at g of 4. So let's see, I have everything now at this point. 1 over f prime, g of 4 we just figured out is 12. And then in this problem, they actually also give me f prime of 12, which is negative 5. So this is the derivative of the inverse. Again, the idea is you can find the derivative of the inverse function without actually knowing the inverse function equation. Okay? So pause the video, try number 2 on your own, and then check it. Okay, same thing here. So we're going to let g of x be the inverse of f. I give you a point on f. I give you the derivative, and let's go ahead and do the same thing. So step 1, we want to find g of negative 2. So again, this is what I'm looking for. But I know g and f are inverses, so I know that negative 2 is the same as your y value on f. But I know that this is 3, right? F of 3 is negative 2, so that means this is also 3. So g of negative 2 is 3. Now let's find the derivative of the inverse. So the formula for the derivative of the inverse is 1 over the derivative of the original function evaluated at the inverse. And then I have 1 over f prime of g of negative 2 is 3. And f prime is given is 5. So there's my derivative of the inverse. Okay, now let's get another problem, but this one, the numbers are going to be given in a table, but same idea. So here, okay, this little d dx is telling you that I want you to take the derivative of whatever this is. So it's saying find the derivative of the inverse at 1. Okay. You can work with this notation if you want, the little negative 1 exponent, but if you don't like it, if you want to do this, this would be fine. You just have to state it. So let's just call the inverse of f of x, we'll call that g of x. Okay, so I know that on g, so let's figure out our formula. So I know the derivative of the inverse is going to be 1 over f prime of g of x. And I want to know what happens at 1. Oops. Right, so let's just go ahead and plug in the 1 for x right here. So let me get rid of that. And we'll just go ahead and plug in the 1. So there's my general formula. So look at your formula, see what do you need. I need g of 1 somehow. So I need to figure out what this is. But I know g and f are inverses. So if I could figure out this value, I can find g of 1. So this is saying, what's the x coordinate that gives me a y of 1 on the function f? So notice that f of x is equal to 1 when x is 2. So that value is 2. So that means this is also 2. So I have 1 over f prime of g of 1 is going to be 2. And then f prime of 2, I can graph from the table at x equals 2. What's f prime? Is negative 6. So there it is. Okay, and then the last thing we're going to do here is now let's write the equation of the tangent line. What do we need to write the equation of the tangent line? We need a slope and a point. So I want to know what happens at x equals 1 on the inverse. So on the inverse, we figured out from above, right? The inverse is the same as g. There's my point. And then we just figured out that the derivative of the inverse is negative 1/6 from above. Again, this is the same as g, so if you want to call it g, that would be fine. So my equation of a tangent line is y minus 2 equals negative 1/6 x minus 1.